we can start. Sorry about that, guys. Can you all see this? You should be able to see VS Code on one side and Advent of Code on the other side of the screen. All right. So what I did is I just set up a new project folder. Okay, cool. So this is called Advent 2022. Yeah, so let's get started. Let's take a look at the first puzzle. I'll shrink this just a little bit more so we can read it. All right, so day 1, calorie counting. So it says Santa's reindeer typically eat regular reindeer food, but they need a lot of magical energy to deliver presents on Christmas. For that, their favorite snack is a special type of star fruit that only grows deep in the jungle. The elves have brought you on their annual expedition to the grove where the fruit grows. Jack PS9, thanks for the raid. Hi everybody, welcome. I should actually, you know what? I should change the settings on my title and description right now. Let's find the right category. Oh, I just saw it. Game and, I think they call it game and software development. There we go. Software and game development. Okay. Advent of Code. Okay. So that should have updated the title. Anyway. Okay, where were we? Yeah, we need star fruits. To supply enough magical energy, the expedition needs to retrieve a minimum of 50 stars by December 25. So that's, you get 1 star for each problem you solve. There's 2 per day. Although the elves assure you that the grove has plenty of fruit, you decide to grab any fruit you see along the way, just in case. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. So we could see on the calendar that days 1 through 11 are already open. Day 12 will open in a little while, so I've got some catching up to do. Yeah, I'll show you that, Zinc, sure. All right, so let's go back to day 1. All right, the jungle must be too overgrown and difficult to navigate in vehicles or access from the air. The elves' expedition traditionally goes on foot. As your boats approach land, the elves begin taking inventory of their supplies. One important consideration is food, in particular the number of calories each elf is carrying. And that is the puzzle input. Okay, so let's get started here. So we'll just start off with day 1. What do I want to call my files here? I'll do a separate file for each day. Yeah, we'll just call it day 1. And I'm going to be programming in Python, by the way. All right, so day 1.py is where we're going to start. And I will, let me increase my font size here too. Font size. No, let me go to settings. Okay, let's try 24. Okay, that looks good. It's pretty big. All right. Right, so our puzzle input is the number of calories each elf is carrying. The elves take turns writing down the number of calories contained by the various meals, snacks, rations, etc. that they brought with them, one item per line. Each elf separates their own inventory from the previous elf's inventory by a blank line. Okay. So this means that elf 1 would have 1,000, 2,000, 3,000, etc., etc. The list represents the calories of food carried by 5 elves, right? The first elf is carrying 1,000, 2,000, and 3,000, which is a total of 6. The second elf is carrying one item with 4,000, and so on and so forth. In case the elves get hungry and need extra snacks, they need to know which elf to ask. They'd like to know how many calories are being carried by the elf carrying the most calories. Okay, find the elf carrying the most calories. All right, so let's look at what our input is. Right now, it sounds simple when they're explaining it here, right? But then when you get your actual input, it's like, yeah. All right, so what I'm going to do here is I will just select all. I'm going to copy that. And then what do they call this? Puzzle inputs. Yeah, so I'll just create a new folder called inputs. And I'll just dump that into a text file, and we'll read it from the text file. Okay, so this is our input. Okay, so what we're going to have to do is we're going to have to go through this list and calculate how many calories each elf has, right? Each elf's calories are separated by a blank line. Jim, I just save it to a file just so I don't have like thousands of lines of input data in the mixed in with the code. And then I'll read it from a file. So I'll read it from the file. When we get to a blank line, that means that that means we're dealing with a different elf, right? Okay, and then the answer to this puzzle is however many calories the elf with the most calories has. So we just have to add up. We'll cycle through this file for each line by line. We'll add up the calories, and then we just need to record what the maximum number of calories is for any single group, and that's going to be our answer, right? Okay, so first we will start by getting the input. Well, here, let's do this. I'll create a function for part 1. Okay, and I'll create another function for reading the input file. So we'll just say get input, and then we'll open up the file. So and this is going to be inputs day01.txt as file. And then I think I can just do return file, read lines. No, except I don't want to do that. Here, I want to clean this up as I do it. So, except I need to preserve those blank lines. Okay, yeah, so I'll just do this. Return file dot read lines, and then that should just give me an array with all those lines in it. All right, so let's just test this to see how it works. Get input. We'll just print it, and then I'll just call part 1 here. So let's run that and see what happens. Okay. Yeah, so I can see that I've got all my lines. Now in this case, each line is, it's actually coming through as a string, and there's a new line character at the end of each one, right? So I think I'll just leave it like that for now. Okay, so we'll say, what are we calling this? We'll just say data equals get input, right? So that'll load our data. And then, let's see, and then we'll just iterate through. So for each line in data, what are we going to do? So what we'll need to do is we need to keep track of the maximum calories. Okay, so we'll initialize max calories equals 0. And then as we go through, the first thing that I'll do is if line equals, or let's say if line is not equal to a new line, for line in data, hang on a second. Okay. Let's just call this current calories, right? Because I need to add up the calories for each ELF, and then I need to compare it to the maximum. All right, so we'll start with both of these as 0. So if I don't have a new line, that means I'm still dealing with the current ELF, right? So in that case, current calories, I'm going to add I need to convert it to an integer. I think that'll work. Let me try here real quick. I think that'll strip off the new line if I do that. That doesn't want to work. Let me try something here, just so I can test it. All right, so let's say I have a string that's 1, 2, 3, 4 with a new line at the end, int a. Okay, yeah, that'll work. All right, so if it's not a new line, we'll just add the current count to the calories, right? And if it is a new line only, then what do we want to do? If it is a new line, that means we're done adding up the calories from the current ELF that we're looking at. So at that point, we say if current calories is greater than max calories, then that's our new maximum. Then max calories equals current calories, and then current calories equals 0, right? Because we have to reset it. And I think that's it. And then we just print max calories. Or tell you what, let's return max calories, and I'll print it myself. Okay, I think that should work. And then down here, we'll just do if name equals main. Oh, I'm using double quotes these days. Let's be consistent. Then we'll do print part 1. And then we'll just print the result of part 1, right? And then when we do part 2, we'll just add another line. Okay, so let's run this and see what happens. All right, I get 778,000. Ah, yeah, JC, good point. Yeah, that's a good point. It has to know that that's the end. Let's run it again. I wonder if we get the same answer. Okay, we get the same answer. Let's see if we're right. So now we plug in that number, submit. It's not the right answer. It's too high. Okay. Why is it too high? Let's see here. All right. For line in data, which is all of this, if it's not equal to a new line, then we add the number to the current calories. And then we go back again. Yeah, good point, Jim. Let's use the sample data. I'll have to format this. Right. So I'm going to need these to all be strings, right? Although I could just, yeah, you know what, let's make this easier. I'll just rename this temporarily. That's the real data. Okay. So let's see if we get the same answer using the test data. We get 24,000. Okay. So I do get the right answer with the test data. Reset the current calories outside of the if statement. Ah, right. Right. Yeah. That's where it was wrong. Because what I was doing is if the current calories, if it was the new maximum, then I was resetting the current calories. But if it's not the new maximum, I still need to reset the current calories. Yeah. All right. So let's, here, let's call this test. Okay, now if we run it, all right, I get 70,000 and something. I think that's going to be the right answer. Yeah, there we go. Yay. Yeah, you can do multi-line strings in Python. Jonathan Paulson. I'll have to check him out, Zinc. Yeah. Other people are a lot better at this than I am. I'm not a I'm not a professional developer yet, although I am working on it. I'm in the process of making a career transition because I really enjoy this stuff. I love coding. And I'm getting better all the time. It just takes practice like everything else. Okay, so now we'll do part 2. Let's see how we do there. 60 seconds. Yeah. Yeah, you know, yeah, some of those guys, like the guys who are really good at this, I think they take pride in doing it with the fewest number of lines possible. But I often need to debug my solutions a little bit. So I'm a lot more verbose because I want it to be readable to make it easier to debug, you know. Yeah, I should stop using an admin account. That's what everybody tells me. But it's my gaming rig. This was actually the yeah, this was the account that was set up for me when I bought the computer. Okay, let's go to part 2. By the time you calculate the answer of the elf's question, they've already realized that the elf carrying the most calories of food might eventually run out of snacks. To avoid this unacceptable situation, the elves would instead like to know the total calories carried by the top 3 elves carrying the most calories. That way, even if one of those elves runs out of snacks, they still have 2 backups. Okay. Find the top 3 elves carrying the most calories. How many calories are they carrying in total? Okay. So I think this is not going to be a whole lot different. So I'll just copy the code from part 1. Now in this case, we're going to want to keep, we're basically going to want an array, or in Python parlance, we're going to want a list of the top 3. All right, so let's just create, and this is where we'll store the top 3 elves. Okay, and in fact, I think we can even initialize it with 000 to start with. All right, and then as we go through the data, we get the current calories. Now in this case, we need to check if it's greater than any of the 3 that are in there. Yes, you can sort a list in Python. Right, so in this case, once we get a maximum, or once we get our calorie count, we need to check it against the minimum value in the top 3. Or you know what we could do? Yeah, I think I know what we could do here. Okay, so when we're done, right, so instead of max calories, we're only going to need the top 3. All right, so I have an idea here. I'm going to work this out as I go. And here, and at the end, we're going to return the sum of the top 3. Okay. Yeah, so what we could do is we could take our top 3 and we can append current calories. Yeah, and then we can sort it. So let's see if I can remember how to sort a list. I've been doing a lot of JavaScript lately, so my Python is a little bit rusty. Okay, so it's just the array followed by sort, and we want to reverse it. Right, so we'll add the current count to the top 3, and then we'll go top 3 dot sort reverse equals true, and then top 3 equals, oh, and then we can pop off the last one. Yeah. So we take our list of 3. We add each result to the end of it, so then we'll have a list of 4. We'll reverse sort it so that it'll be highest to lowest, and then the pop will remove the last one on the list. And then at the end, so that way we'll still only have 3 at the end. I think that'll work. So let's try this with our test data first. Okay, so in this case, we should have 45,000, and I got 41,000. Okay, so this didn't work quite right. Here, let's just print it so I can see what I'm ending up with. 24,000. No, where's 24,000 coming from? That's not right. Oh yeah, the fourth elf has 24,000. All right, so 24,000, 11,000, and 6,000. Those are the top 3. And that adds up to 35. That adds up to 41,000. Oh, the 5th elf. Okay. Ah, I know. I have to add the blank line to my test data. That's not super clean. All right, then I get 41,000. Okay, now I get the right answer. But I don't like that I have, oh no, it should be 45 now still. I still didn't get that. Okay. All right, so let's do this. Let's print top 3 and current calories. Let's just see what I'm getting at each step of the way. All right, so I start off with 3 zeros and a 6. Then I get 6. Then we add 4,000. Then 11,000 gets added. Okay. Then 24,000 gets added. But 10,000 never gets added. Let's do this again at the end. Yeah, actually, it never even shows me 10,000. It's like the, maybe this is not really a new line. What if I do that? 45. Okay, now it works. And that probably means I need another new line there too. Okay, so let's get rid of that. Let's get rid of that. Right. Okay, so I get 45,000, which is the right answer. Okay, so now let's do it with the real data, and I get 203,002. Yay! Okay, we got it. Good job. Thanks, guys, for the help. Appreciate that. All right. So I'm thinking, how could I improve this to handle the last blank line better? so that if it just gets to the end and there's no blank line, I don't think as quickly when I don't think as quickly when you guys are all watching me. I can see this is a bit of an issue here. Yeah, I'm just thinking like if I can make this part independent of it not being a new line and just being the end of the data. All right. Well, I'll come back to that one. Anyway, we got it working. That's the important thing. Let's go to day 2. Is that the single line solution, Zinc? Can you check for new line or end of file? You know what? I could check to see if it's the last line. Like if the line is not equal to new line, or you know, I could check to see if the index of this line in data is equal to the end of data. What's that command? I mean, that's kind of clunky too, though. I feel like that's... This is the single line solution, Zinc. That's crazy. I can't even understand that. Yeah, I think, or yeah, what if it's a new line? Yeah, I don't know. There's a way to do that, and I know that if I think about it a little bit, I can figure it out, but I'd rather just go to the next day right now. Let's just do that. All right. So let's do day 2. The elves begin to set up camp on the beach. To decide whose tent gets to be closest to the snack storage, a giant rock, paper, scissors tournament is already in progress. Okay. Rock, paper, scissors is a game between 2 players. Each game contains many rounds. In each round, the players simultaneously choose one of rock, paper, or scissors using a hand shape. Then a winner for that round is selected. Rock beats scissors, scissors beats paper, and paper beats rock. If both players choose the same shape, the round instead ends in a draw. Appreciative of your help yesterday, one elf gives you an encrypted strategy guide, and they say will be sure to help you win. Okay. The first column is what your opponent is going to play. A for rock, B for paper, and C for scissors. The second column, and then suddenly the elf is called away to help with someone's tent. The second column, you reason, must be what you should play in response. X for rock, Y for paper, and Z for scissors. Let's take a look at the input here. Right, so there's a bunch of ABCs in the first column and a bunch of XYZs in the second column. Since you can't be sure if... Oh, I'm sorry. Winning every time would be suspicious, so the responses must have been carefully chosen. All right, so let's add a few notes here. So A equals rock, B equals paper, C equals scissors. I guess it doesn't really matter what we call these things. And then X equals rock, Y equals paper, and Z equals scissors. Okay, so we know that on our input. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores for each round. The score for a single round is the score for the shape you selected, plus the score for the outcome of the round. Okay, let me put that down. Round score equals score for shape, which is 1, 2, or 3 for rock, paper, scissors. Thanks for the sub. Appreciate that. Plus the score for the outcome, which is 0 for a loss, 3 for a draw, and 6 for a win. Okay, that's the score for each round. Since you can't be sure if the elf is trying to help you or trick you, you should calculate the score you would get if you were to follow the strategy guide. Okay. All right, so I'm gonna start by copying a few things from day 1. All right, so in this case, the input will be day 2. And then the test data, I'll just enter manually in this case. Why does it do that? All right, so the test data is going to look like this: AY, BX, and CZ. Right, and we can put all that on one line. Okay. So part 1, and then I'll also copy this here. Part 2, that's going to be a pass, and then that'll run it. Okay. All right, so this strategy guide predicts and recommends the following. This is for the test case. In the first round, your opponent will choose rock, and you should choose paper. That makes sense. This ends in a win for you with a score of 8. Because we played paper, that's worth 2 points. And then it's a 6 because we won the round. In the second round, he chooses paper, and you should choose rock. Paper beats rock. That ends in a loss. So that's 1 point for choosing rock and 0 points for the loss. And then the third round is a draw, scissors and scissors, giving you a score of 3 plus 3, right? So 3 for choosing scissors, and then 3 for a draw. Okay, that makes sense. And that would give us a total score of 15. Okay, so let's figure out how to implement this. All right, so first of all, we're going to have to cycle through the data. Let's save our test data. And I'll add a line at the end. Okay. So, Yeah, so we can just call each one a round. So we can say for a round in, and in this case, we're just going to use the test data. First we need to format it. So we'll say round equals round dot strip. That'll take off the new line characters. Okay, let's not call this round. Let's call this, what do we call this? A play, a choice. Yeah, we'll call it choices. And then we'll split on the space. All right, so let's just see if that works properly. Okay, so I know it might be hard to read what I have down here, but basically what that's given me is this. Okay, so it just gives me, for each one I get a list with the elf's choice and then my choice. Right, so that just separates out the values. Okay, and then we can calculate our score. So the tricky part is mapping out what beats what. And I'm thinking, for each choice that I make, there's a win and there's a loss and there's a draw. Win, loss, draw. So maybe we can make a dictionary. Let's call this results. And we can base it on my choice. Would that work? No, I would need like, well, I could do it in a specific order. I could do, like, for example, if I pick X, yeah, we'll have to do 2 dictionaries. Oh, yeah, you can do that, Jim. Yeah, like, for example, in this case, you could do elf me. At least I think that'll work. Let's try it. Yeah. Yeah, so you can assign it to values right out of the gate. Okay, so if I choose X, then if outcomes, yeah, here, let's call this outcomes. So if I choose X and my opponent chooses X, then the outcome is going to be a draw. Or no, and the opponent chooses A, then the outcome is going to be a draw. So that'll give me a score of 3. If he chooses B, rock, then that is a loss. And if he chooses C, then that is a win. Right? Now, if I choose paper, then in that case, a rock is a win, paper is a draw, and then that must be a loss. And then if I choose scissors, then rock is a loss, paper is a win, and scissors is a draw. Right, so this way I can map my choice to a result based on what the other choice is. All right, so we could say outcome equals outcomes me elf. All right, and let's just test this. We'll just print the outcome for each round. 6, 0, 3. 6 because I won. A loss is 0. Okay. So that's good. So those are the outcomes. And then let's do the same for scores. Right, so in this case, we get a score for each shape. So X gives me a 1. Y gives me 2. And Z gives me 3. Okay. Right, so basically what this does is, like when I say score equals scores me, so me is going to be my choice in each of these rounds. So I put that here in scores, and then it looks up what my choice is, and then it returns the value that's assigned to that. So that's how this works. Right, so if I do outcome plus score, 8 plus 1 plus 6, 8 plus 1 plus 6. All right, and then we'll do total score equals 0. And so we'll just add outcome plus score for each round. And then at the end, we return total score. Okay, so if I run that on my test data, I get a 15, and that seems to work. All right, so actually let me, in this case, I'm going to remove the blank line at the end. I don't want that. All right. So now instead of the test data, we'll use the actual input. And I get 13,446. Let's see how we did. Yay, I got it. First try. Love it. I am a genius. And yeah, there's probably somebody that did that with like a single line of code that's only 23 characters long. But anyway, this is how this this is easier for me to follow inside my own head. All right, part 2. The elf finishes helping with the tent and sneaks back over to you. He says, anyway, the second column says how the round needs to end. Ah, okay, so now we're getting a different interpretation of how this works. X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. Okay, so now this is a different dynamic. All right, so X equals loss, Y equals draw, and Z equals win. Okay, the score is calculated in the same way. Okay. So I think, so we follow, I guess we follow a similar type of a strategy, but in this case, XYZ means something different, right? Okay, so how can I do this? All right. Well, it's gonna follow a similar method, but I'm just gonna have to have a different mapping. All right. So let's go back to the test data. This is the same. Although in this case, instead of elf and me, what we're really getting is elf and the desired outcome, right? All right, so if the elf chooses all right, so in the first one, the elf chooses a rock, and we need to end in a draw. That means I need to choose rock. So basically what I need to do is I need to, I need kind of a reverse lookup on outcomes so that whatever the elf chooses, I need to make my choice the one that that gives me the score. So like if I need to have a draw, for example, then I need to choose the one that'll give me a 3. And if I need a win, then I need to choose the one that has a 6. And if I need a loss, then I choose the one that has a 0. Okay. So do I want another mapping? Yeah. All right, so let's do this. And I'm just kind of working this out in my mind as I type. So my choice, I think we can, maybe it would be easier if I even just did a function for this. Because if I know the elf's choice and the outcome that I want, then I can algorithmically determine what my choice should be. Right, so let's just do this. We'll make a function called choose, and I will pass it the elf choice and the outcome that we want. Okay. So, and I can use this, I think I can still use this structure. All right. So if I need a draw, this is going to get a little bit complicated. I think I need a different data structure. Because now it depends now it doesn't depend on what I choose and what the elf chooses. In this case, it depends on what the elf chooses and what outcome I want is. So let's make a different, let's just call this, I don't know, we'll call this choices. We'll make a new data structure for this. Okay, so we'll start with the elf's choice, and then we will map that to specific outcomes. Okay. Here, let me move this up here. Okay. So if the outcome is a loss, if the desired outcome is a loss, then my choice, So if it's a rock and I want to lose, then I need to choose paper. Okay. If it's going to be a draw, then I need to choose rock. And if it's going to be a win, then I need to choose scissors in this case. Or no, rock, a win. Yeah, a win is paper. Sorry, that should be a Y. Okay. I think I'm doing this the right way. All variable names must consist only of the letter A or be automatic variables. Yeah, right. Okay, so if the elf chooses paper, a loss to paper would be rock. A draw to paper would be paper. And a win to paper would be scissors. And then if the elf chooses scissors, then a loss will be paper, a draw will be scissors, and a win will be rock. So YZX, XYZ, YX. No, this one's wrong. If the elf chooses rock, a loss is paper, a draw is rock. Yeah, this should be scissors. No, scissors doesn't beat rock. A loss is scissors. A win is paper. All right, so ZXY, XYZ, YZX. All right, so I think this is right. Jeez. Okay, so choose, in this case, so I'm just going to return, well, actually, I don't even really need the function now, do I? Since it's going to be a single, it's going to be a single line function. All right, so in this case, elf choice and outcome is what we're getting from the data, right? And then we can say me equals choices and it's based on the elf choice and the outcome. Okay. And then I need to, let's see. Right. So, and then the rest of this should basically be the same, although I think I'm going to have to change something. All right. So we already know the outcome, but I still have to convert the outcome to a score. Well, I can do it the same way. I can do it the same way, right? Right? Like if here I'm starting with the desired outcome and figuring out what I choose, but then at the end to get the outcome score, it's still the same. Outcomes, my choice and elf choice. It should be consistent. Yeah, so the rest of this should be the same. I don't know. Let's try it. Let's run it and see if I get the right answer. So I get an answer of 12. That seems right. All right, so let's try it with the actual puzzle input. and I get 13,509. Let's see if that works. Yay, I did it. Okay, so that wasn't too bad. That involved a lot of setup, but the actual algorithm was fairly simple. Right on. 2 down. Only use emojis. That would be awesome. Okay, I think we got time for one more. Let's see what we can do with day 3. All right, so before I go to day 3, here let's do this. Day 0. Here, let's call this a template. Whoops. Right, because on nearly every one of these, I'm gonna have this at the end. I'm gonna have this at the beginning. And here, let's do this. We'll make this more generic. Right, we're gonna have a part 1. Oh. And we're going to have a part 2. All right, so I can use this as a template for each new day that we do. Part 1, part 2. There. And we'll add a blank line at the end. All right, so then I can just copy that. I can make my day 3 file and then paste that in, and then we're basically ready to go. Okay, one elf has the important job of loading all of the rucksacks with supplies for the jungle journey. Unfortunately, that elf didn't quite follow the packaging instructions, and so a few items need to be rearranged. I think I know where this is going. Each rucksack has 2 large compartments. All items of a given type are meant to go into exactly one of the 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item type per rucksack. All items of a given type are meant to go into exactly one of the 2 compartments. Okay, so that means you can't mix item types between the 2 compartments. Right? So let's just kind of take a few notes here. The elf that did the packing failed to follow this rule for exactly 1 item type. Exactly 1 item type didn't follow rule. Okay, elves have made a list of all of the items currently in each rucksack, but they need your help finding the errors. Every item type is identified by a single lowercase or uppercase letter. Okay. The list of items for each rucksack is given as characters all on a single line. Got it. A given rucksack always has the same number of items in each of its 2 compartments. The same number of items. So the first half of the characters represent items in the first compartment. Okay, and the second half represent items in the second compartment. Okay. So first half equals compartment 0, and second half equals compartment 1. All right. So this is our test data. So let's throw that in here right away. Why? Okay, and then I just need to encase these each with quotes. Oh, it's not going to be friendly with me on the formatting. Okay, so that's our test data. All right, so the first rucksack contains all of this, which means this first compartment contains this, and the second compartment contains, whoops, don't mess with it. The second compartment contains that. The only item type that appears in both compartments is small p, which is this one. Okay, and there are multiples of each. I don't know if we need to count these yet. I guess we'll find out. The second compartments, okay, so L for the second list, L is the one that's common in each. Okay. To help prioritize item rearrangement, every item type can be converted to a priority. Okay. So items have priority based on what they're called. Oh, okay. So the priority of the item type that appears in both compartments of each rucksack is based on what the character is. So the first one is a lowercase p, which is a 16, 38, etc., and then the sum, right? So that's how we convert it into the number that we need to give for our answer, or like we reduce it to that. Okay. All right. Let me pull up string dot, yeah, there's a way that we can get that easily. I think we have to import string, and then we can do string ASCII letters. Let's see what that looks like real quick. Okay, yeah. All right, so we'll do priorities, priority equals string ASCII letters, right, which is this. So when we come up with something, we can calculate its score based on its index in this string. Okay. All right, so let's try to do this with the test data. All right, so the first thing we need to do is split it in half. Okay. So for rucksack in test data, compartments, or I'll just say compartment, equals rucksack how do we want to do this? I want compartment to be an array, or I just need it to be a string actually. Okay. For item in rucksack, and we'll slice it in half. All right, here, let's do this. I'll just simplify it a little bit. All right, so compartment 1 is going to be that. And compartment 2 is going to be that. And actually I can remove the 0. So basically what we're doing is we're just splitting it in half. And let's just print those just to make sure that we're getting what we expect. Okay. Right, so this is what I get for the first one. For example, this is compartment 1, which goes through the lowercase r after the big W, so that's right. And then the other one is the H to the small p. Okay, so this looks good. So there we just split it into the 2 compartments. Okay, and then we can go for item in comp 1 if item in comp 2, then that's our answer. And I think there's an easier way that we can do this. I think I can do a list comprehension here. Let's see. We'll just call this common item equals oh geez. Item for item in comp 1 if item in comp 2. I think that might work. Let's try that. Little p. Oh, okay. This is weird. Why am I getting multiples there? So basically what this does is it's just going to cycle through every item in compartment 1. And if the same item is in compartment 2, then it adds it to the list. Oh, okay. I see why I'm getting multiples, because the same one appears twice. So really, as soon as we get a hit, we can stop. So this is a pretty concise way to express it, but it does mean that we're going to iterate through more characters than we really have to. So let's make it a little bit more efficient. So we'll just do a for loop. Does sorting have any? I don't think sorting these is going to make any difference really. Okay, so we'll just cycle through the items. Let's try that. So we'll do for item in comp 1 if item in comp 2, then yeah. Okay, here we'll do this. I don't think I need to put that. I don't think I need to initialize it. If item is in comp 2, then common item equals item, and then we can break. Let's try that. I don't know if that's going to break out completely. Yeah, little p, l, p, v, t, s. Okay. So this way it'll just stop as soon as it finds a match. Yeah, Zinc. Yeah, you can get, part of this game is not only to solve the puzzles, but like if you jump on it as soon as it's released, then you can get you get score based on how quickly you solve it compared to everybody else. I'm not going for speed at all. I'm just going for correctness. If I can get through all 25 days and get the right answer, then to me that's a victory, and I'm good. Okay, so we are getting the correct common items by using this algorithm. Okay, so I need a sum, right? So let's initialize the sum as 0 when we start. Okay, so for each rucksack, I'm getting my common item. And what I want to do is sum. I want to add the index of that common item in the priority list. Right, so priority.index common item, and then I need to add 1. I need to add 1 to this because when you get the index starts at 0, so the first character in this is going to be a 0. But in this case, we need to start at 1. So I just need to add a 1 to whatever that index is, and then return the sum, and that should be it. Let's test that. I get 157. 157. Okay. So let's try it with the real data now. Get input, and then in this case it's going to be, oh, I didn't save my data yet. All right. Inputs day 03.txt. All right, let's get our input. We'll copy that. Okay, looks like there's 300 rucksacks. All right, and let's close this. All right, and I get 7716. All right, we got it. That wasn't too hard. No, we don't need a new line in that case because we're not using new lines as any kind of a separator or anything. So, yeah. So in that case, it works. Actually, you know what? It might be adding a new line character. Let's check something. Comp 1, comp 2. Oh, okay. Yeah, it looks like the new line character is getting stripped off as I do this. I would actually oh, okay. Yeah, actually it is keeping the new line character at the end. So if we wanted to get rid of that, we could just say we could just do that. Oh no, we can't do that. For a rucksack, yeah, so the rucksack, and then there, and then we could just strip it. If you do strip, it'll get rid of any new lines or leading or trailing white space. Right, so you could do that. In this case, it doesn't matter because the new line is only going to be in the second one. But it could potentially create a problem because that new line is counting as part of the length of the string. So I think this is a little bit cleaner. And I think it'll give us the same result. Let's just run this again just to check. 7716. What did we answer? Yeah, 7716. Okay. And let's do this. I like to record what my answers are just so I can If I change anything, I can make sure I get the same result. Okay, let's go to part 2. Part 2 is really long. All right. As you finish identifying the misplaced items, the elves come to you with another issue. For safety, the elves are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency, within each group of 3 elves, the badge is the only item type carried by all 3 elves. Okay. That is, if a group's badge is item type B, then all 3 elves will have the item type B somewhere in their rucksack. And at most, 2 of the elves will be carrying any other item type. Within each group of 3 elves, the badge is the only item type carried by all 3 elves. Okay. And at most, 2 of the elves will be carrying any other item type. That part I don't quite understand. Oh, okay. Or maybe that means that at most 2 of the elves will have anything else in common. I don't know. Let's keep reading. The problem is that someone forgot to put this year's updated authenticity sticker on the badges. All the badges need to be pulled out of the rucksacks so the new authenticity stickers can be attached. Additionally, nobody wrote down which item type corresponds to each group's badges. The only way to tell which item type is the right one is by finding the one item type that is common between all 3 elves in each group. Okay. Every set of 3 lines in your list corresponds to a single group, but each group can have a different badge item type. Okay. So in the above example, the first group's rucksacks are the first 3 lines. All right. And so we have to figure out like which character is common between those 3 lines. And the second group's rucksacks are the next 3 lines. Let's look at our sample data. Okay, so 3 and 3. They don't overlap, thank goodness. In the first group, the only item that appears on all 3 rucksacks is lowercase r. In the second group, it's Z. Priorities for these items must still be found to organize the sticker attachment efforts. So here there are 18 for the first group and 52 for the second group. The sum of these is 70. Find the item type that corresponds to the badges of each 3 elf group, and then what is the sum? Okay. So in this case, we have to, here we don't care about the compartments. We just have to take each set of 3 lines and find out which is the one common character that's in all 3. And then get the priority and then add those all together. Okay, so this doesn't sound too terribly difficult, but let's see. All right, so once again, we'll start with the test data. But in this case, we actually need to pull these in groups of 3. So I'm going to use an index instead. Okay, so let's do this. So we'll just say for I in range length of test data. Here, let's do this. Data equals test data. And then later I'll change this to get input. Okay, so for I in range length of data divided by 3, And that's a floor division, so that guarantees that we get an integer. And I know that we already know that the data has 300 lines, right? So it'll come out nice and even. And we want to step in threes. This is not working. I thought that I could just put a blank. Let me try this again. Oh, range. Okay, yeah. So range has to start with 0. It ends with that. And we're going to step in threes. All right, so if I run this, I get a 0. Let's add 1 to that. I still get a 0, and then it stops. Length of data should be 6. 1, 2, 3, 4, 5, 6. Yeah, so I don't need to do a +1. Oh, okay. I don't need to step in threes, actually. There we go. 0 and 1. No. Okay. There we go. Okay, so when I do this, I get a 0 and then I get a 3. All right. So then our three rucksacks equals data from starting from I to I plus 3. And that should give me groups of 3, right? So when I print those, I get this. Okay, so the first set are the first 3, the second set are the next 3. Okay, so that's good. And that's putting those into an array called rucksacks. All right. And for efficiency, what I could do is I could cycle through the shortest of those 3 until I find a common item between that's in the other 2 as well. All right, so how do I figure out which of the 3 rucksacks is the shortest one? I can sort it. I can sort it based on the length of each one. And then if I print, and then the first one in the array should be the shortest one. Let's see. Yeah, so in this case, it's this one for the first set. And it's this one for the second set. Okay. Does that really save us time though? Because to do this, to sort them, I have to go through each one, and I have to calculate the length. To calculate the length of each array requires it to cycle through the entire array. So I think this is actually going to make it slower than if I just pick the first one in the list. So it seems like this is going to save time, but this is actually going to take longer because by checking the length of each of the 3 strings, I have to cycle through all three of them. Whereas if I just take the first one and cycle through the whole thing, I only have to cycle through one array one time. So, although, no, I take that back, because when I check to see if each of these characters is in the other two strings, it has to search through each one again. So I think this is actually worth it. Okay. So then we'll just go for item in rucksacks 0. If item in rucksacks 1 and item in rucksacks 2, then common item equals item, and then we break from the loop. And let's just test this. Let's just print what the common item is. So I get a small r and a big Z. Okay, so that works. Algorithm works. And then the sum, we calculate the same way as before. Yeah, and then return sum. And that gives us an answer of 70. So we're looking good for the test data. It says that there's only one item that is going to be common between all three. And Jim, that's a good question. Let's see. No, I don't want to log in. How do you do that? Oh, okay. Yeah, it looks like it's just, there's not a function for that, but you can do a list comprehension like this. So this is, I think this is a longer way to write it, but you could do it like this instead. Right, like we could do, here, let's comment this out. Item for item in rucksacks 0 if item, whoops. Right, you could do this. Will it let me do that? Yeah, I think it will. Right, so you could do it this way, and then you just have to specify common item 0, because it'll end up as an array with a single element. I think that'll give us the same result. Yeah, 70. Yeah, to be honest, I kind of like that better than this, because I don't like using a break. Although the break is nice, because then it'll stop as soon as it gets a hit. And this is an expensive calculation, so I think it's actually better to use. I think it's actually better to use the for loop with a break, Because like if I get a match on the first character, then it's not going to have to go through all the rest. So I think I prefer it this way. All right, so let's do it with our real data. All right, so I just replaced the data with the data from the file. And we run this, and we get 2973. Let's see if that's right. And it is. I'm batting 1,000 so far. All right. What was the answer there? 2973. All right, cool. Okay, so off to a good start. But I am out of time, so I think we will pick this up in the next stream. We can do some more. So we got 1, 2, and 3 solved, and plenty more to go. So I think we'll be doing this. If people are still interested, we'll be continuing this after Christmas. So I'm not going to get. I don't think I'm going to catch up if I'm only doing this once a week. But yeah, this is fun. I enjoy doing this. Hopefully you guys liked watching it. And I'm going to run. So I will see you all next time. Thanks for being here. Thanks for the support. Thanks for helping me get unstuck a couple times here. And I will see you all next week. Take care.